In this video, we're going to show you how we exploited the ExtraReplica vulnerability chain and how attackers could potentially use it to attack Azure PostgreSQL databases at will. So, we have here on the screen two separate accounts belonging to different organizations. On the left is our research account with the Wiz email address. This is the account we're going to use to perform the exploit. The victim account on the right with the Gmail email address is a completely separate and unrelated account. You can see that the attacker's database and the target database are not part of the same subscription. Switching to the victim's view, we connect to the database and create a table that contains our valuable information. This is the same information that we will attempt to disclose as attackers later in this video. We create a table named secret that has a single entry with the value confidential information. The victim's instance is configured with Azure's default network configuration. We will modify the firewall rules for this instance to deny any connections to the database. This should theoretically prevent malicious actors from connecting to our database instance. However, by leveraging the ExtraReplica vulnerability, the attacker will be able to connect to the database internally through Azure's network, completely bypassing this firewall rule. Let's see what happens when we try to connect to our database. As expected, the connection times out. Our next step towards exploiting this vulnerability is to reveal the internal identifier of the database we want to replicate. For each Azure PostgreSQL instance, a new certificate is issued. The certificate contains both the public server name and the internal database identifier. We reveal the internal server identifier by querying the public certificate transparency feed with the public PostgreSQL server name. Prior to recording this video, we generated a certificate that can be used to exploit the vulnerability. If we inspect the certificate, we can see that it has a specific subject name under the wiz-research.com domain. Next, we will abuse a flaw in the code Microsoft introduced to the PostgreSQL engine. This flaw allows us to elevate our privileges and execute arbitrary commands on the PostgreSQL instance at the operating system level. Using a malicious SQL query, we will invoke a reverse shell from the virtual machine hosting our PostgreSQL instance. After reverse shell connects, we'll issue the Linux ID command to reveal that we are currently running as an Azure DB user. Next, we will attempt to connect to another PostgreSQL database in our internal subnet, and you can see that the connection fails due to a TLS error that reveals the internal name of the database we tried to connect to. And what do you know? The internal name of this database matches the internal name of our target database, the one we wanted to exploit. We download our specially crafted certificate and its corresponding private key to the machine and start the replication process. Next, we create a tar archive of the replicated database and transfer it to our own compute instance using Netcat. Now, we can extract the tar archive and attempt to restore the replicated database. We connect to the restored database and query the secrets table. As you can see, it contains our confidential information entry. Thank you for watching. For more information about the ExtraReplica vulnerability and more, check out our blog at wiz.io/blog.